This video is on finding domain. And before we do that, let's just talk about notation. So first notation we'll talk about is set builder notation. Set builder notation, you may have seen in the past. We'll look at it through an example just to kind of remember what it was. If I said, for example, write x is greater than 8 in set builder notation, the way you do this is typically a set is written inside of curly braces. So you start with a curly brace, and that means the set. And then you put the variable, in this case it's x, so we put x here. This means a set of all x. And then we put a bar here. This bar means such that. And then you put the condition, in this case, x is greater than 8. And then you close the set with a curly brace. So the way we'd write this is the set of all x such that x is greater than 8 is how you would use set builder notation there. More commonly, you'll probably see interval notation. So for interval notation, typically, if you have a greater than or equal to or a less than or equal to, in interval notation, you'll be using a square bracket, right? And, depending on which side of your inequality, you have your value, will determine if you use a bracket or not. For a greater than or a less than, you use parentheses. So this is just me speaking generally about it. It's not going to necessarily be parentheses on both sides, brackets on both sides. It's just saying that when you have an equal to, you use a bracket with that part. If you don't have an equal to with it, you want to use a parenthesis. So we'll do some examples of this just to make sure that you remember how to use these. So if we said to rewrite each inequality in interval notation. Well, when I say interval notation, we're going to be using parentheses and brackets, that means, as opposed to the set builder. So for the first one, right, if I said I had 2 is less than x is less than or equal to 6. So what I like to do sometimes is first draw myself a number line, just because that helps me, visualize what I want to write for the interval. So if I draw a number line here, you don't have to put 0 on it or anything like that, but just thinking about what values you need. You need 2, you need 6. This is telling me I want all the x values between 2 and 6, right? So my solution is everything between 2 and 6, not including 2, but including 6. When we have this, 2 is less than x, there's no equal to sign, it means we're not including 2. We put an open circle. When you have 6 with the equal to sign, that tells you you're including 6, so it's a closed circle, and the x values are in between. That's what it's really telling you. So my solution is all the x values between 2 and 6, not including 2, but including 6. So in interval notation, right, just for short, we'll abbreviate it. For interval notation here, what do you start with? Well, you're not including the 2. It's an open circle, so you want to use a parenthesis. In other words, you had that, less than didn't have an equal on it, so you didn't include the 2. So it's parenthesis 2, indicating you're not including the 2, but you want everything after it, up until, how high do you go? You go to 6, and do you include 6? Yes, it's a closed circle. Yes, because they had an equal sign. So it's a bracket on that side. So the interval notation here would be, parenthesis 2 to 6 with a bracket, meaning you include everything after 2, but not including 2, up until 6, including 6. Make sure that when you're doing this, you always have it in order from left to right, lowest to highest. Looking at another one here. if I said I had -5 is less than or equal to x is less than 7, well, we could draw a number line. You don't have to, but it might help. Oh, sorry, didn't realize it was off the screen. So -5 is less than or equal to x is less than 7. And we're going to draw a number line. You don't have to, but just so you see it, here's -5, here's 7. Do I include -5? Well, yes, because there's an equal to on that side. So including -5, do I include 7? No, so we put parenthesis on that side because there's no equal to. The x's are in the middle. So how would I write this in interval notation? Well, what do you start with? The first value we start from our left is -5. Do I include it? The answer is yes, because it's got a closed circle. So bracket -5, comma, how far to the right do you go? You go up until 7, and then we put a parenthesis. So that would be the interval notation indicating that interval, right, that inequality. We'll look at a couple more. If I said I had, let's draw this one here. If I said I had, I'll call this letter C, just x is greater than 9. Think about what this means. If you're thinking about a number line, our solution is all the x values larger than 9, but not including 9. So we'll put 9 on my number line, and I'm going to put an open circle here because I'm not including it, right, because there's no equal to there. And I want the x's greater than 9. Greater than means larger than. Values larger than 9 would be to the right. So if I was writing the interval notation that went with this, where do I start? Well, my first value to start with is at 9. Do I include it? Well, it's got an open circle, so no. So it's parenthesis 9 up until, how far does this go? Well, it goes out forever. So you put infinity here. On the side with an infinity, or on a negative infinity side, you always use a parenthesis because it's an idea that it goes out forever. You can never attain the value. You can't get to infinity. And we'll look at another one. If I said I had, say x is less than or equal to -7. Just box in this answer so you can see it's separate. X is less than or equal to -7. Again, I'll draw a number line. You don't have to, though. I'll put -7 on there. It's the only value you have to worry about. Is it included? Well, the equal to there tells me yes, it is. X is less than or equal to -7. Less than means numbers are smaller. It means to the left. So my arrow is going that way. And I want to write my interval notation from left to right. So the lowest to highest. Well, how far does this go to the left? Well, it goes out to -infinity. So you start with parenthesis because you can never include the infinity. It's an idea. So you're going out to -infinity. How far to the right does it go? Well, it goes all the way up until -7, and it stops. So we got -7, and then we put a bracket because you're including the -7. All right, if it was an open circle, you put a parenthesis there. Let's just take a look at a couple more. If I was to write, say I called that D, I'll call this one E. If I was to write the set of all x such that x is less than or equal to -4, or x is greater than 5. If I wanted to write this as interval notation, this is really two subintervals. Think about what this means if I was to put it on a number line. We need -4. We need 5. When x is less than or equal to -4, the equal to tells you you're including it. X is less than -4 would be values to the left. For x is greater than 5, are we including 5? Well, no, there's no equal to, so it's an open circle. How far do I go to the right? Well, I'm going forever to the right, because x's are greater than 5. And so if I wanted to write this in interval notations, I really have two intervals, right? We have the union of two intervals. This is when we see or, sometimes we call this the union, so we use union here to describe or. And start from left to right. Well, from the left, how far out to the left does this go? It goes to -infinity. It goes up until, well, it stops at -4. Do I include -4? I do, so I put a bracket. Now when I say use the union, we use this U symbol for union. It means or. All right? And then we start back up. Well, where do I start back up? I start at 5. It's an open circle, so it's a parenthesis, 5. How far over does it go to the right? Well, it goes all the way out to infinity. and then parenthesis on the side with the infinity. So that would be the interval notation there. So, you know, it's not necessarily going to be just one interval. You could have multiple intervals that are in your solution, but you have to make sure that you know how to write them. Let's take a look now at some examples. All right, so we're going to look at some examples. We're going to find the domain. So remember what domain was. Domain is our set of all possible, I'll say x values, right? It's really all possible inputs for a function. You know, we have another video where we do this graphically, but we're going to do it algebraically. So to find domain, algebraically, for a function, we look for what I will call problem points. Now that's not an official mathematical term, it's kind of just a way to think about it. So I'm looking for problem points. When I say problem points, you know, really what you want to do is you want to figure out where the function might be undefined, right? So what I'm really saying is where it's undefined or not real numbers. Right, and you're going to try to exclude these, right? So you want to keep these out of my domain. In other words, you're excluding them because you want to have only the x values that make your function have a y value as well. All right, so they're not part of your domain if they don't give you a real value for your function. So we'll do a few of these. All right, so this example here, I'll kind of give you the information as we do the examples. So if I said find the domain of each. Now, when I talk about where things can be undefined, that means zero denominators, right? So if there's a possibility for a zero denominator, you have to look for that. When I say not real numbers, typically this comes up when you try to take the square root of a negative value. So we want to look to see where that could happen. So those are the things we're kind of looking out for. So for the first example, if I wrote f of x equals 9 over 3x minus 7. All right, so this is a function, right? It's called f of x. And you want to know where is this, you know, either undefined or not real. So if I'm looking for where it's not real, I'm really thinking, are there any square roots here? In this case, there are no square roots, so we don't have to worry about having, you know, imaginary answers, in other words, when I say not real. But you do have to look for where it's undefined. When I'm looking at a fraction, it's undefined, right? When? Well, it's undefined when the denominator equals 0. So what I really want to do is I want to figure out where 3x minus 7 equals 0, and then exclude the x values that cause that to happen. Right? That's how I'm going to find the domain, because that's the problem point. The problem point is the one that makes this come out to 0. So what I do is I take 3x minus 7, and I set it equal to 0, and I'm going to solve this. So when I go to solve this, you know, I add 7 to each side. I end up with 3x equals 7, and then we're going to divide by 3. So I divide by 3 and divide by 3, and I get x equals 7/3. Now remember, what do I want to do with this? This is what caused it to be undefined. So I'm going to exclude, right? We're going to exclude this from our domain. So you're going to exclude that from your domain. In other words, your domain, which I'll use capital D for domain here, your domain is that x doesn't equal 7/3, because 7/3 would cause this denominator to become 0. Now, if I wanted to write this in interval notation, think about what that means. It means all the other values are good, right, except for 7/3. So if I was to write this on a number line, just to give you an idea, you know, here's 7/3, it's a number, it can be on a number line. we would end up with an open circle on the 7/3, so you can't include it, but everything else over here would be okay. Everything else over here would be okay. So how do I write that in interval notation? Well, the way you write this, looking at it from left to right, what's the lowest x values? This goes all the way to the left forever. So that'll start at parenthesis negative infinity. How far does this go? Well, it goes up to 7/3, but you can't include 7/3. You can't just say to infinity because you have a break here. So negative infinity is 7/3, and then we put a parenthesis because you're not including the 7/3. And then we put the U for union because now we're starting another interval. Well, where does it start? Well, it starts at 7/3. You're just not including it. So it's parenthesis 7/3. How far does it go? Well, it goes all the way to the right forever, so it goes to infinity, and then a parenthesis because you never include the infinity side. So that would be the domain in an interval notation. All right, so we're looking for problem points and we want to exclude them. If I gave you another one, let's take a look here. If I had if I said we had g of x equals the square root of 5x plus 21. Now, remember, we're looking for where it either has a zero denominator, and we want to exclude that, or whatever would cause this to not be real. So, are there any denominators I have to worry about? Well, in this case, no, right? There's no fraction here, there's no variables in the denominator, there's nothing to worry about there. Is it possible for us to get not real answers, right? And the truth is yes, because you have a square root. So if this inside ever became negative, you would get answers that weren't real. So the interesting thing about a square root is that we can say, okay, the bad points are when this is negative. So what are the good points? Well, the good points are where the inside of this is either positive or 0. So what we really do is we set, right, the inside for a square root. All right, so we set the inside. Greater than or equal to 0. All right. To get the domain, when I say that, these are going to be the good points, right? I'm excluding the negative ones when I say I want the ones that are greater than or equal to 0, right? That's going to give me the positive or 0 values for inside here. All right, so these are, I'll call good points. You know, it's not the correct mathematical terminology, but it's the points you want. It's the points you want for our domain. So if I was looking at this, I have 5x plus 21, and I'm going to take just the inside here, greater than or equal to 0. If you take the whole radical instead of greater than or equal to 0, that's fine. You would just have to square both sides. It wouldn't really change anything because really we want this to come out positive. But typically you set the inside, you're saving yourself a step. Also, for an inequality, you really don't want to square both sides, so it kind of makes it, you know, a little tricky. But 5x plus 21, greater than or equal to 0, right? Set that inside, so it becomes positive or 0, and then we want to solve this. So I solve this by subtracting 21 from each side. I end up with 5x is greater than or equal to negative 21, and then divide by 5, divide by 5. I get x is greater than or equal to negative 21/5. It's okay to leave this as a fraction. Actually, you should leave it as a fraction. I would prefer that over to leaving it as a decimal unless this was an applied problem. So this ends up being the domain. You found the good points because we excluded the bad points by doing this. So the domain is x is greater than or equal to negative 21 over 5. If you were going to write this in interval notation, think about what the number line looks like. If I was drawing a number line, you have negative 21/5 on there. You want x to be greater than or equal to. The equal to tells you it's a closed circle. Greater than tells you the numbers are larger, so you're going to the right with it. So if I was to write this in interval notation, right, my domain would start where? Well, it starts at negative 21/5. Remember, you're always looking left to right. Do I include it? The answer is yes. So you need a bracket because there's a closed circle. Negative 21/5, comma, how far out does this go? To infinity, parenthesis on the side with the infinity. Basically, what we just found is this whole interval is all the x values that cause us to become 0 or positive. If you use negative 21/5 and substitute that in there, that'll give you the square root of 0, which is just 0. Everything larger than that will be a positive value. Now, it might be an irrational value. You know, it might not simplify nicely as a perfect square, but that's okay, right? It's just a matter of you want to make sure that the values you find, these are the good points because we set the inside greater than or equal to 0. We wanted it to become positive in here. It's the causes a real answer. The only way you get a negative answer out of a square root, right, is if it was a negative. The only way you get an imaginary answer or a non-real answer out of a square root is if the inside was a negative. Let's look at this one. If I said I had h of x equals 4x to the 5th plus 3x squared minus 9x plus 2. And you really have to ask yourself when you're looking at this, okay, are there any problem points for this function? Well, when we say problem points, remember I'm looking for, are there any places where it becomes undefined? Well, in this case, there are no denominators at all, so it's not possible to become undefined. And are there any places where you can get the square root of a negative? Well, there are no square roots in here, so there's no way of making it a non-real answer. So there are no problem points, and that's okay. If there are no problem points, that means all x values are possible to be input and get a y value out. So in this case, our domain then is just going to be all real numbers, which in interval notation we write parenthesis negative infinity to infinity. Right? That's all real numbers. All the x values you sub in will give you a y value out. How about we look at this one here? This one's a little trickier. Combines a couple things we've talked about. If I said I had f of x equals 5 over the square root of 3x plus 9. So we know a couple things here. We know that I'm looking for either where it becomes undefined or where you have negatives under the square root and exclude those points. So for the 5 over the square root of 3x plus 9, first off, it's a fraction, so could it become undefined? Well, yes, it becomes undefined when the denominator equals 0. So the first thing we should notice is that the denominator, right, can't equal 0. Right? So we can't have the denominator equal 0. But the other thing is that we also have a square root in the denominator. So since we have a square root down here, we actually have to make sure that this also doesn't become negative. Now with a square root, typically from what we learned above, right, we take that radicand, the inside, and we say that we want it to be greater than or equal to 0. But we know it can't be 0, right, based on what we just said. So we want to take the inside and just make it greater than 0. So we set 3x plus 9 just greater than 0. We don't put an equal to because in the denominator it can't be equal to 0, right? So that's why there's no equal to on this. If this was in the numerator, you would keep the greater than or equal to on the inequality. Remember, these are going to be the good points, right? These are the points that cause the inside of the radical to become positive, which is what we want. We just don't want it to be negative. And in this case, we also don't want it to be 0. So this will give us our domain. So 3x plus 9 is greater than 0. We subtract 9 from each side. End up with 3x is greater than negative 9. And then we divide by 3 and divide by 3. I end up with x is greater than negative 9 over 3 does reduce to negative 3. So we have x is greater than negative 3. This is the domain. All right, you found it. Now once I have that domain, you may want to look for it in interval notation. Typically we'll ask for it in interval notation. So in interval notation, you know, you don't necessarily have to draw a number line for yourself every time. I'll do one quickly here. We have negative 3 on the number line. We have an open circle because we're not including it. X is greater than that would be to the right. So the interval notation for this domain, you would start with parenthesis, right, left to right, parenthesis, open circle. So yeah, negative 3. How far out does it go? Well, it goes out to infinity, parenthesis, always on the side with the infinity. So negative 3 to infinity, all right, would be our domain. These are the x values that when substituted in give us a real number answer out. It's not undefined and it's not imaginary. If you included, right, if you had an equal sign on here and you included the negative 3, what would have happened is you would have gotten 3 times negative 3 down here. If you give you a negative 9 plus 9 would give you a 0 denominator. The square root of 0 is okay because then you get 0, but then 5 over 0 would be undefined, and that's why you can't do it. We'll look at a few more. So if I gave you this example here. We've got, what letter is that? That was D, so this one will be E. If I said we had, I'll call this h of x, equals the square root of 2x plus 6 over x minus 5. So now we're combining a few different things. Remember the things you're supposed to be looking for, right? You're trying to eliminate the problem points. The problem points occur when either the denominator equals 0 or when you can get negatives under a square root. So in this case, let's talk about the denominator. So when does the denominator equal 0? All right, so the denominator, we know we can't have it equal 0, so we have to exclude when it does. So the denominator equals 0 when x minus 5 equals 0, right? That's me just looking at the denominator. And you want to solve this and then exclude that value. So we'll say we add 5 and we add 5. So you get x equals 5. And remember what I said, you want to exclude this. All right, so exclude this from your domain. So we know x doesn't equal 5. Now that's not the only thing we have to look for. You know, sometimes people will just set up this with the not equal right in there, and that's fine if you want, just knowing that you're not including the point. So x doesn't equal 5, we know that can't be part of our domain. But you also have to look at your numerator in this case because you have a square root. Only because you have a square root you're dealing with the numerator. You don't deal with the numerator if it wasn't a square root. But in this case we have a square root, and we know that we want to take this and we want to set the inside greater than or equal to 0. And remember, these are the good points. So we have this for the denominator, and we also have this for the numerator. So for the numerator, we have 2x plus 6. We want that to be greater than or equal to 0. In this case, it could equal 0 on the numerator. A 0 numerator is okay, it's just a 0 denominator that isn't. And then we're going to solve this. Well, to solve this, I'll subtract 6 from each side, end up with 2x is greater than or equal to negative 6. And then we'll divide by 2, and divide by 2. So we have x is greater than or equal to negative 3. Now notice this word I wrote here, and. So you want both of these properties to hold, right? So x doesn't equal 5, and x is greater than or equal to negative 3. All right, so and is really what they have in common. When you see an and in one of these problems, right, if with inequalities, we're saying and is what the intersection is, what they have in common. So, you know, this is the domain, but we're going to write this in a more compact form. So let's talk about what happens. I'm going to draw it on a number line. All right, you don't have to, but to write this in interval notation, I think it'll be helpful. So you've got negative 3 and 5 are the numbers we're looking at. So here's negative 3, and here's 5. Now we know x doesn't equal 5. So I'll put an open circle at 5, but everything else is good. Now sometimes people will draw this out. Sometimes people will just say, okay, I'm not including 5, and then be done with that. They don't think about it. And then you got x is greater than or equal to negative 3. Well, if x is greater than or equal to negative 3, that means I have a closed circle at negative 3. All right? And then x is greater than that, means I want everything to the right. So if I was looking at just the part from negative 3, it would be everything to the right of it like this. But the part from 5 says, okay, I'm not including 5, but I'm including everything else, right? So it'd be everything like that. And what I'm saying is I want the overlap, what they have in common, all the good points. Well, the good points are where x doesn't equal 5 and x is greater than or equal to negative 3. Well, where is that? Well, x is greater than negative 3 and not equal to 5 all in here, and not at 5, and then all over here. Right, and there is an overlap right at negative 3 itself, right? So this is where I just shaded in is where, if I was to draw it on a more, clear number line, I'd have negative 3, I'd have 5, And what really happens is I start at -3, I shaded in everything up until 5, not including 5, and then I shaded in everything after that. So that's really what the number line would look like. Now, you don't have to draw a number line, but it might help you see the problem. The domain itself, now, we write based on this. Well, where do I start? I start from left to right, -3, I include it, so it's a bracket, -3. How far do I go? I go up until 5. I don't include 5, so we have 5 and then a parenthesis. Now, you can't just say -3 to infinity. You need to have this break at 5, because 5 is not included. And then union, and then I start back up at 5, so it's parenthesis 5, just not including 5. And how far out do I go? Well, I go out forever to infinity, parenthesis on the side with the infinity. So the domain here is from -3 to 5, including -3, not including 5, union, and then picking up right after 5 to infinity, but you're not including the 5. It's important to recognize that that you have to look at what meets both the requirements, right? The requirements of the numerator and the denominator. Because if I was to pick something that fell into one category but not the other, I could either get an undefined part of this or get something that's not real. For example, if I substituted 5 in here, right, 5 minus 5 for x would give me 0 right away. So that would give me a 0 denominator, it'd be undefined. But also, if I picked any number that was to the left of -3, suppose I picked something like -4, the denominator would be fine. You'd have -4 minus 5 would give you -9, that's fine. But up in the numerator, you have the square root of 2 times -4 would be -8 plus 6 would be a -2. The square root of -2 is not a real answer, right? Not a real number. It's imaginary. So it would not work for our function, because we're talking about real number values when we're looking at our function. So that's why it's important that you meet both requirements. That's why I put and here. This won't happen often, but if it happens, you have to know how to handle it. Let's just take a look at a couple more. If I said I had this one here, y equals 4 plus x over the square root of x minus 9. Remember what we're looking for. We're saying, all right, where are the problem points? Can the denominator become 0? Well, yes, it does become 0 if the x minus 9 is 0. All right, so we know the denominator can't equal 0. So we got to watch out for that. And also we want to make sure that anything under a square root is either 0 or positive. Now remember, we already said it can't be 0, but we want to make sure this is positive. So our setup for this is just to set x minus 9 greater than 0, kind of like the one we did 2 problems ago. Mainly because, right, your denominator can't equal 0, so you don't have the equal to on the 0 here. But all the good points are everything that are positive, right? Anything above 0, you can take the square root of. It might be irrational, but it's still going to be a real number. The numerator, don't worry about in this case. 4 plus x doesn't have any problem points in it. We only worried about the numerator in this case because you had a square root up there, right? But down here, you don't worry about the numerator. So just solving this, all right, I'll add 9 to each side. I get x is greater than 9, and that is the domain, right? We found the domain. When you find these good points, you're finding the domain. And how would I write that in interval notation? Well, even without a number line, you probably can see it. X is greater than 9. You would start at 9 with a parenthesis. All right, so parenthesis 9. How far does it go? It goes to infinity. Close parenthesis, and that'd be your domain. All right, and let's just talk about one more example that kind of goes along with what we're saying here, where we'll talk about feasible domain. So in this example here, I'll say suppose $3,000 is invested at a rate of 5% compounded quarterly for T years. And part A, I'll say give a formula for the amount A in the account as a function of time t. So first off, compounded quarterly is giving you information. We're talking about an interest rate. We're talking about compounded quarterly. So if you remember our formula, say recall here, in case you haven't seen it, our formula is A equals the principal times, in parentheses, 1 plus I, which is the interest rate as a decimal, over n, the number of times you're compounding per year, to the nt power, right? So that's the general formula. For us to write it as a function of time t, like they said here, A we'll call A of t, that's what makes it a function. It's saying, you know, like f of x, A of t, right? So the function A, the amount at a time t, is equal to, now principal, they told us the information we need. The principal is the amount initially invested, so that's our $3,000, times 1 plus I is our interest rate as a decimal. So if I have a 5% interest, remember 5%, to convert it to a decimal, remember what you're doing. You're taking the decimal place, you're moving it back 2, so it'd be 0.05. You could also, remember, divide the percent out of 100. 5% out of 100 would give you 5 divided by 100 gives you 0.05. So it's 1 plus 0.05 over n. N is compounded quarterly, so it's telling you n equals 4 times a year. And to the nt power, n we just said is 4 times t. Well, we don't know what it is. It's a function of time. So you're going to leave it as t. Don't substitute in for it. You want that t to be in there, right? This is A of t. You need a t in this formula. And simplifying this formula, if you were to take A of t, it's equal to 3,000 times, this is really 1 plus 0.05 divided by 4 comes to 0.0125, all to the 4t power. And then adding these together, you end up with A of t equals 3,000 times 1.0125 to the 4t power. And this is A as a function of t, right? So if I gave you a time t, right, you could substitute it into here, right, and find A of t. So if I said find A of 4, you would substitute 4 in for t, and you could evaluate the amount in the account after 4 years. Part B to this question, which is really why we're doing this. First part was just trying to give you a refresher. Part B is to state the feasible domain for part A. Now when I talk about domain here, my input value is t, so it's in terms of t, just like our x values. But what I'm really talking about is, okay, this is a function here. Now, are there any problem points? Well, typically I said look for where the denominator would be 0, and I don't have any denominators coming out to 0 here. Or where you'd have the square root that would come out negative. Well, I don't have any square roots in here, so I don't have to worry about square root coming out negative. So there are no real problem points. But the thing you have to keep in mind is this is an applied example. So what values can t take on? Well, t, again, is time, right? It's a time t in years. And what's the least number of years you can have to what's the largest number of years you can have? So when I talk about what's the least number of years you can have, the lowest value for years is 0 years, right? You just make the investment and no time has passed. So that's a real time. You can't say negative years, so we can't include any negative values, but we can include 0. So the domain will start at 0, including 0. And how far out does it go? Well, time really goes on forever, so it goes to infinity with a parenthesis. So it's not a hard question to answer. The domain is from 0 to infinity, including 0. But the problem with it is that sometimes people don't recognize that the premise of the problem, right, as stated, is actually giving you, the idea of where the feasible domain would be. If this was just a function given to you and I didn't tell you any information about it in terms of that it meant something in time and years, it was just a problem that I said, here's the function, right? There were no problem points. you could say negative infinity to infinity for the domain, but because this is an applied problem, the years matter, and you have to think about what's the lowest number of years you could have to what's the highest. So hopefully this was a good refresher on domain, also using interval notation. And there's another video that talks about domain and range graphically that kind of goes along with this, so I'd recommend watching both.